Welcome once again, Akshar IIT online classes. After a long time, hope celebrated Vinayak Chavithi holidays. Enjoyed, right? Good students. So today once again, welcome back to our track to studies. Right. So students, in the last class we have discussed about the language of chemistry, and we discussed, I gave the number of elements, so many elements, and how the elements names were given, how to represent their symbols, and everything we discussed, right? And even I think I might have given a valencies to you also, right? So once let us see valency, and today I am going to explain you how to make the formulas of the compounds, right? So in the chemistry, we can see some millions of compounds are there, not like one or two, not our hundreds or thousands, some millions of compounds are there. So these millions of compounds, how they form? By the combination of elements. Elements combine to form the compounds, right? Already we discussed this one, like water is formed when hydrogen combines with the oxygen, and the carbon dioxide when carbon burns in the oxygen, sodium chloride when sodium reacts with the oxygen. So like this, so many like ammonia, like this nitrogen combines with the hydrogen, right? But how many elements will combine to form a particular molecule? What is the ratio of these elements in a given particular compound, right? So to know this one, you need to know the valencies. You should know the valencies of the elements, right? So now let us see here about the valency. Is it visible? Yeah. Valency. Valency means what? Combining capacity of an atom or of an element. Anything you can write, no issue, it's not a problem. Combining capacity of an atom is called valency. So here, combining capacity means what? One particular element combines with the other elements to form a compounds, but with how many number of other elements it will combine. So that is called valency. And I think I might have given a valences of the first 20 elements to you, and I said you to learn the valences of those elements, right? And if you already learned, then that would be very better. And if you didn't learn, then once if you open the material page number 20, the page number 20 and even 27, synopsis 4 also, there are elements with valencies over there. So here, very quickly, I'll write few elements valences very quickly, and today we'll discuss how to make the formulas of the binary compounds. Binary means what? Only two. The compounds that are formed from only two elements, right? So see students, here very fast I am writing here, only symbols I am writing and their valences. So see here, okay. So hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine, So these are atomic number basically. I'll give the valences. 1 minute. Fluorine and neon. Next come to the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and 18 argon, 19 potassium, 20 calcium, right? So say students, valencies, combining capacity. So just I am writing valencies 1, 0, see 1, 2, 3, 4, 3, 2, 1, 0. Again 1, 2, 3, 4, 3, 2, 1, 0. 1, 2. So very easy way, you can remember that one. So here you see, first one 1, second one 0. The helium is inert gases. General inert gases valence is 0. And then you see here 1, 2, 3, 4, 3, 2, 1, 0. Once again see here 1, 2, 3, 4, 3, 2, 1, 0. And 1 and 2. Right. So these are the first 20 elements valences. This already we discussed in the previous classes. Now today I am going to see how these valences are given. That depends on the electronic configuration. How these valences have come. This valences depends on the electronic configuration. So we'll discuss the electronic configuration in the next coming classes in detail. Okay. So in the atomic structure chapter, now we are discussing about the language of chemistry. Right, students? Ciao. So now let's see. I'm going to explain you the how to write the chemical formulas of a chemical compounds. And here I said the chemical compounds. In this we are going to discuss only about the binary compounds. Binary compounds means what? The compounds which consist of only 2 elements. How many elements? Only 2 elements. Right? They are called as a binary compounds. Okay. So here now first I will explain you few elements, few compounds, and then you see here, for example, I want to write the formula of sodium chloride. So see students, here I want to write the formula of sodium chloride. So first I'll explain you some. Okay, I'll explain you here. First example, let's take the sodium oxide. Sodium oxide, right? And then we'll take the magnesium oxide. Magnesium oxide. Then I will take the aluminium oxide. Aluminium oxide. Right? So I've taken the 3 compounds here. One is sodium oxide, second is magnesium oxide, third one is aluminium oxide. Now how to write the formula for this one? So see students here. Here formula is nothing but a representation of a compound by using the symbols, okay, of the elements. So sodium, and you know the sodium symbol is Na. So I'll write Na, right? And oxide. Oxide means what? Oxygen. Okay. So here oxygen symbol is O. Okay. Now just see, observe here. Afterwards we'll say. Now magnesium. So magnesium symbol is Mg. Oxide means again oxygen. So oxygen symbol is O. Aluminium oxide. Aluminium symbol is Al. And oxide means oxygen. Oxygen symbol is AlO. Right. So sodium oxide. Sodium is Na. Oxide is O. Magnesium oxide. Mg is magnesium. O for oxygen. Aluminium oxide. Al. Aluminium symbol and oxygen symbol is O. Now I have written like this. Now whether these formulas are correct or wrong. If you check, so the first formula is wrong. Right. Now let's see the second formula, magnesium oxide MgO. Yes, this is correct. Then we see the aluminium oxide formula AlO. This is wrong. Now the question arises, why? Here sodium oxide, sodium symbol and oxygen symbol written NO. This is wrong. But a magnesium symbol is magnesium Mg. Oxygen symbol is O. I said this is correct. Again aluminium is Al. Oxygen symbol is O. These are written as is, but it's wrong. Why? Because here we didn't follow the valency, combining capacity we didn't follow. So combining capacity is different for different elements. Here we have seen. Yes or no? So different for different elements. So that's what these formulas, okay, wrong. This is and this is wrong. This is only correct. Now let us see how to write the formulas. So see now students. Sodium oxide. When I want to write the formula of sodium oxide, first write the symbol of sodium, that is Na. This you know. Then oxide, there is no oxide, oxygen. Oxygen only called as a oxide. So now when it's combined with the other elements called as a oxide. So oxygen symbol is O. You write O also. This first step is correct. But now what you have to do? You have to check for the valency. Sodium valency. So sodium valency is what? 1. So here I'll write the 1. This is sodium valency 1. Right? Now then go to the oxygen. Oxygen. Oxygen where here is the oxygen. Oxygen valency is 2. So write 2. Okay. Now what you do? This valencies crisscross them. Crisscross them means what? The exchange. Like sodium valency, you write it to the oxygen. Oxygen valency, you write to the sodium. Then what happens? So see, oxygen valency come to the sodium. So this becomes Na2. Now sodium valency go to the oxygen. So oxygen, this sodium is going for this one. So 1. If 1 is there, you need not write about the 1. So just neglect it. So this becomes Na2O. So now that is the formula of sodium oxide. That is the formula of sodium oxide. Na2O is a formula of sodium oxide. Clear? Right? Now I'll give one more. So magnesium oxide is there. Magnesium symbol is what? Mg. So I'm writing Mg. So right here Mg. And oxygen symbol is what? O. So I'm writing O. Right? Now see the valences now. This first step is correct. Now go to the second step. Second step is what? Writing the valences. Writing the valences. So the magnesium valency is what? Magnesium valency is 2. So now write the magnesium valency 2. And then you write oxygen. Oxygen valency is also 2. So oxygen valency is also 2. Right? Now crisscross them. So crisscross. So this becomes what? For magnesium, oxygen valency will come. But oxygen valency 2 only. So this is writing 2. Now then write oxygen. For the oxygen, the magnesium valency come here. So we write it 2. Now when these two numbers are same, since you can cancel it. You can cancel it. In the mathematics, generally we can cancel the numbers, no? Like this we can cancel if the numbers are same. So now left with what? MgO. MgO. That's all. This is the formula of magnesium oxide. Clear? Chalo. Now I'll write the aluminum oxide. Then I'll give some compounds to you. You have to practice. And then I'll give some other things also work to you. Aluminum oxide. Aluminum. Aluminum symbol is what? Al. Okay. So I'm writing the Al. And oxygen. Oxygen valence is, sorry, first we write oxygen. So first write the element names. So element symbols we have written. Second step is what? Note down their valences. Aluminum valence where it is 3. So write the aluminum valency 3. And then note down the oxygen valency. Oxygen valency is 2. So oxygen valency is 2. Right? Now crisscross them. Means what? To aluminum you write the valency of oxygen. So that becomes 2. And for oxygen you write the valency of aluminum. So 3. So then it becomes Al2O3. So this is the formula of aluminum oxide. So now see students here, all are oxides only. Sodium oxide, magnesium oxide, aluminum oxide. But formulas you see Na2O, MgO, Al2O3. So that is different. So that is making the formulas. Is this clear to you? Just note down and within 1 minute, and then I'll explain something regarding this one only. Today we are going to discuss about the compounds. Okay. So once if you want to note down for 1 minute, right? Chalo. Okay, students now. Then now let us come to the, for example, here the compound which is forming between sodium and oxygen, we are calling it as a sodium oxide. Here the compound is forming from magnesium and oxygen, we are calling it as a magnesium oxide. Here aluminum and oxygen, the compound is formed is called aluminum oxide. Okay, we leave the oxygen out till here. Now let's go to some other elements. Okay, for example, if you want to write the compound which is forming between like what do you take? Magnesium and nitrogen. Okay, I am taking like this, magnesium and nitrogen. Okay, so I want to know that if the magnesium and nitrogen, if I mix together, if I make to combine them, then what compound is formed? The first. What is its formula? There's a second one. Then how can I call it as? There's a third one. Okay, so now, here students here, magnesium when we are reacting with the nitrogen, what's a new compound is formed? Means when magnesium burn in nitrogen. So generally, when magnesium if you burn in air. So here, magnesium can form magnesium oxide also, magnesium nitride also. Two compounds are formed. Can you say why? Yes, because air is a mixture of gases, right? In that oxygen is present nearly 21% and nitrogen is present nearly 78%, right? And remaining of course 1% of very other gas are present. So nitrogen and oxygen are the main components of the air. So the magnesium when it is burned in air, some of the magnesium may react with the oxygen, some of the magnesium may react with the nitrogen, right? So when magnesium is reacting with the nitrogen, what is the compound formed? The name of that compound is magnesium nitride. What it is called? Magnesium nitride. Actually, it's reacting with the nitrogen. But when the compound formed, then what the name should be given to this one? Nitride. How we are given like oxide, oxygen, we are given oxide. So nitrogen, we give the nitride. So magnesium nitride. Clear? Now what is the formula for this one? Same as usual. How we written? So write the magnesium symbol Mg, nitrogen symbol N. This is the first step. Then second step, what we do? We write the magnesium valency. What's the magnesium valency? 2. We write the 2 here. And nitrogen, what's the nitrogen valency? 3. These are 3 here. Then second step, what we do? We crisscross them. We bring the nitrogen valency to magnesium. And we bring the magnesium valency to the nitrogen. So magnesium, we write nitrogen valency, that is 3. And the nitrogen, we bring magnesium valency 2. That's all. So here it is magnesium nitride formula. The formula when the compound formed between magnesium and nitrogen is called magnesium nitride and its formula is Mg3N2. Clear? Right. Now you stop. Now if you want to write the formula of beryllium chloride. Chalo students now. You write the formula of beryllium. First let's see beryllium chloride. Okay. So the compound which is formed from the beryllium and the chlorine. When beryllium is reacting with the chlorine, then what the name you call it as and what is its formula. Chalo try now fast, 1 minute. First what you do? Write the beryllium and then chlorine. Then what you do? Write the symbols below the beryllium and the chlorine symbol. Then what you do? Write the valences. Then what you do? Crisscross them. Then write the formula, final formula. Then give the name. Beryllium and chlorine. See students here. Beryllium and chlorine. Right? Beryllium symbol is B. Chlorine symbol is Cl. Beryllium valency is 2, C on the board. Here. Chlorine valency is 1, C on the board. Here. Now write the beryllium valency to the chlorine, chlorine valence to the beryllium. So this becomes Be1, Cl2. As I told that if it is 1 is there, you need not to write. So this becomes what? BeCl2, beryllium chloride. Okay, now what's the name will be given? So here see beryllium, don't touch anything, write beryllium as it is. But chlorine should be written as chloride. See here oxygen is written as oxide, nitrogen is written as nitride. Now this can be written as beryllium chloride. Beryllium chloride. So did you understand now how to write? Yes. Now students, what you do is, here the 20 elements are there. In that helium and argon, leave it. Helium, neon, argon. So because their valency is 0, they don't combine, leave it them. Now remaining 17 elements are there. Now you mutually combine those elements. You take one element from here, one element from like this. You can take the elements, and you frame the you frame the formulas for them, and you give the name to them, right? But see, students, there is one small problem is there. Okay, while writing that, there is a small problem is there. Now, for example, if I want to write the formula between lithium and beryllium, does lithium and beryllium combine? The answer is no. Alright. So, how can we come to know? That also one. Now, I'll explain you. See, in a proper way that you can understand. Now, at present situation, you can understand it. But reason behind it, I'll explain in the coming classes. Right. So, see, students here. Here in this 20 elements are written. In this, some are metals are there. Some are metalloids are there, some are non-metals also there. This already we discussed metals, metalloids and non-metals, right? So here generally metals exhibit the valency of positive. How they get positive? I'll explain. So remember now at present you remember this one. Metals exhibit the valency of positive valency. Non-metals exhibit the negative valency. And metalloids, they exhibit both negative and positive, that I'll explain. Okay. So now what you do, I'll explain why, but now you see here. So hydrogen is there. So for hydrogen you write a +1, 0. Now see here students now. 1, 2, 3, 4, 3, 2, 1, 0. Here increasing now. 1, 2, 3, 4. Increasing. So remember that in that way. So this is plus, increasing. Now 4, 3, 2, 1 decreasing. So take minus. Okay. So like this you take the balance 0, 0. Now again 1, 2, 3, 4. So write plus. Now you take 3, 2, 1, 0 decreasing here. Right. So take minus. Okay. So like this. Are you follow now? Now again 0 leave it. Now again increasing plus. So for increasing numbers you write the plus. For decreasing number you write the minus. That's the first thing you remember after our selection reason. Then here metalloids. See here it is increasing 4 again it is decreasing. So carbon has a 4. You can take it as plus or minus. You can take it as plus or minus both the. And here also you can take silicon. So silicon is written plus. So you can take plus or minus anything you can take. Of course, in this some other elements also can exhibit a plus or minus. But as of now, you take only these numbers. So see here, hydrogen is +1. This is helium, neon, argon. These are 0. You don't touch them. Leave it. Right. Now then go to here. Here 1, 2, 3, 4. Increasing, so plus you write. Again hereafter decreasing, so minus. Again plus 1, 2, 3, 4, plus. And again decreasing from here, minus. Again it's +1 and +2. Okay, so first you remember this one. Okay, very easy now this one. Now, after this, now how can you make the compounds, your own compounds? How can we make? So you can combine one positive element, one negative element. Here, wherever written positive, mostly there comes under metals. Whichever written as negative, there mostly comes under the non-metals, right? So here, while combining, what you do is metals and non-metals you combine. Metals and non-metals means what? Positive and negative you try to combine, right? So, like for example, any one element you can take from the positive first. Here is whatever you want to take, you can take. Alright. So, for example, which number you want to take? Any positive. Positive here, what we can take? Okay, I will take. Yes, friends, you can take. Okay, I'll take this calcium because this is a positive number, no? So, first you take the positive number. Right. So I'm rubbing this one, sodium oxide, magnesium oxide, calcium oxide, aluminum oxide. This I'm rubbing. Okay. So this I'm rubbing. Now we'll go to the one positive element. See, you are going to prepare. At least you are going to prepare From this, you see, students, here you can prepare easily 50 compounds. You can prepare very easily. I'm telling you. Easily, you can prepare 50 compounds from this here of your own. You can prepare 50 compounds from this one, from this 20 elements, right? But okay, so here your work is at least 20. You have to prepare your own compounds, right? So for the 20, how to prepare? I'm going to explain. So first, what I said. First, you take metal elements. Metal elements. Metal means what? Positive elements. Positive means plus I'm writing. So positive elements. First, you take one positive element, right? Then you take one negative element. Negative. Okay, that's called non-metal. Non-metal you take. That is negative element. Negative means what? I'm writing the minus. Now frame. Now frame the compounds. Metal, so I said, positive element, for example, the last one, because I didn't take till here, okay, I'll take the calcium. So here I'm taking calcium, right? Now I want one non-metal element. Non-metal means what? Negative. So take one negative element, anything you can take, you have wish. Okay, I'll take phosphorus here. Here phosphorus is minus is there, right? So, okay, I will take phosphorus. Clear? So, what I am doing? First, I am taking metal, which is positive, valency, and second, I am taking one non-metal, that is negative valency. I have taken two elements. One is calcium, that is positive, and second is phosphorus, that is negative. Now, I want to create one formula. When I mix these both, calcium and phosphorus, then what compound is formed? The name and what is the formula for that, right? That I want right now. So first step is what? First step is done. Take the metal, second is non-metal. This is the first step. Now second step. What is the second step? Second step, you take the symbols, write the symbols. Calcium, symbol is what? C. Right? Next phosphorus. Phosphorus symbol is what? P. P. Right? Now what I said, write the valencies. Third step, write the valency. Calcium valence is what? Plus 2. So you need not write plus 2, just write 2. So this is plus 2. And then phosphorus. What is the phosphorus valency? Minus 3. Don't write minus, just write 3. Then next step already you have seen, you have to exchange them, crisscross. So bring phosphorus valency to the calcium. Bring calcium valency to the phosphorus. So what happens? Ca, and this 3 is coming here, right? Now phosphorus. This 2 valency of calcium is going to the phosphorus. So that's all. So this is the formula. Is formed. Now between the calcium and the phosphorus, I got one compound, but I don't know what is its name. I want to give the name to this one, right? So what is the name of this one? Already I told you. First, metal name don't change. Don't change the metal name as it is. You write calcium. Alright? Phosphorus is there. Can you write the phosphorus as it is? No, that is not individual. It is combined. So for oxygen, if it is combined with what I written? Oxide. Nitrogen, it's combined. What we written? Nitride. Chlorine, if it is combined, what we written? Chloride. Now phosphorus is combining with this metal. Then what is we write? Phosphide. What do we write? Phosphide. Over. Clear? So calcium Ca3P2 calcium phosphate formula is. Now in this way, you can take, see I'm telling you, easily, very easily 50 formulas you can make it. Okay, just starting you have seen now. I made with oxygen only, I made with sodium oxide, magnesium, aluminium, like this aluminum oxide. Yes or no? So you can take one positive element, for example, lithium is there. So with this lithium, you can combine negative elements. Whatever the negative elements are there, combine. So where is the negative? So negative Cl lithium with the nitrogen because minus is there. Lithium with oxygen, lithium with fluorine, lithium with phosphorus, lithium with sulfur, lithium with chlorine. So see, with lithium only you will be getting 6 compounds here. Yes or no? So you will take the beryllium positive, Again take all the negative elements, combine. Like this, at least 50 formulas you need to prepare. This is your homework team, right? So from first 20 elements only I am asking. Now from first 20 elements only with that to binary compounds. Binary compounds means only two elements will combine. Here only you can easily estimate 50 compounds you can make. And in the periodic table, how many elements are there? 118 elements are there. Only binary compounds are existing? No. Binary means not only two, but there are so many compounds are there which are, okay, 3, 4, 5, so many combined elements will combine, right? So students, hope that today you understood how to write the formulas of a binary compounds. First, you have to write the positive element, that is metals, generally comes metals. Sometimes non-metals also may come. Sometimes metalloids also may come. For example, you see here, carbon is not a metal. But if carbon reacts with oxygen, what happens? If you burn the carbon with oxygen, what happens? Right? So, see here now, if carbon burns with oxygen, what happens? Here I am writing, so this is exactly middle so that you can see very clearly. So now what happens here? Carbon, it's not a metal, and if it's reacting with oxygen, then what happens? So you know that carbon symbol so is C, first you write C, oxygen symbol is O, that you write. So here carbon has a plus or minus 4, yes or no? But here you have to take plus only. Why? Because oxygen is always negative. So oxygen is always negative. So opposite element should be positive. So that's what you take the positive here. So plus 4 or plus or minus leave it. Just write the valency, that is 4. Right? Now oxygen valency is minus 2. So just you write it 2. Now crisscross. Right? So for carbon oxygen valency comes, that is 2. For oxygen carbon valency goes, that is 4. Now see here C2O4 is there. Yes friends. Now see here, this is 2 ones are 2 twos are. We can cancel. In the mathematics you have studied, no cancellation. So now 2 ones are 2 twos are. Means what, the ratio of carbon is 1 and oxygen is 2. And what I said, if it is 1 is there, you need not write. So CO2 over. CO2. What's the formula of CO2? I think you know CO2. What's the formula of CO2? Formula CO2 represents which compound? Carbon dioxide. Carbon dioxide. Right? Now you may get one question. Okay, so question I will say, answer will say because the time is less. So carbon dioxide. So here sir, you trade magnesium for magnesium nitride you written, calcium phosphide you written, beryllium chloride. Then why not carbon oxide will you written di here? Why you written di? So see students, here carbon is not a pure metal. Okay, it's a non-metal. It's not pure metal. Okay, so that's what it's combining here. Then when two non-metals will combine, then we write this number. Okay, this number is what? 2. In the science, the 2 is called di. In the science, 2 is called what? Di. So that's what carbon. So C for carbon, we are writing as this. This 2 represents di, and this oxide represents O. So carbon dioxide is a CO2, right? So, but here you can't write like this. Here you can't write that calcium diphosphate, something you can't write here. Okay? Acha, this in detail we discuss in the next class. But today what you do? Today you see your textbook page number 20, synopsis 3. Define the valence and significance of the valence. This I explained you. And here only few elements are given, but you 20 elements and their valences with their charge, means like plus or minus, you have to learn, and then based on that you make at least 20 formula students. So in the next class we are going to solve this practice sheet, and you think practice sheet also you can make it, you can do it, but of course no problem, we'll do it, and then we go to the synopsis 4 in the next class. Okay, any doubts? Okay then, so with this we stop our class.